Hello friends, today's question: a homogeneous solid cylinder of length L and cross-sectional area A by 5 is immersed such that it floats with its axis vertical at the liquid-liquid interface with the length L by 4 in the denser liquid as shown in figure. The lower density liquid is open to atmosphere where pressure is P0. Then the density D of the solid is given by. So this is a solid, homogeneous solid cylinder, and immersed in two liquids having a density 2D and D, and it says that the length L by 4 is in the denser liquid. So obviously rest will be in the you can say lesser denser liquid. So in this case we can use concept of the Archimedes principle and try to solve it, as the you can say the solid cylinder is in two liquids of different density. Then the buoyant force will be dependent upon the both the liquids as well D as well as 2D. So you can say using Archimedes principle, the buoyant force acting on the object is equal to the weight of the liquid displaced. Buoyant force acting on the object is equal to the weight of liquid displaced. And as the cylinder is floating, so it means it will be in equilibrium. So we can say when this cylinder is in equilibrium, the buoyant force will be equal to weight of the object. Under equilibrium, which means when object floats, buoyant force is equal to weight of the object. So let's find out the weight of the cylinder. Their object is nothing but cylinder. So let's calculate the weight of the cylinder. Weight of cylinder, and let us say it is WC by L, and this will be equal to density of the cylinder given as capital D, and we have volume of the cylinder and multiply by G, and volume of the cylinder will be equal to area of cross section multiplied by its, you can say, length. Area of cross section is given by A by 5 and length is given as L. Therefore we have that weight of the cylinder is equal to D multiplied by AL upon 5 multiplied by G. So let us calculate now the buoyant force. Now there are two different liquids which are, you can say, not mixing with each other. So let's find out the buoyant force. Buoyant forces, you can say total buoyant force is equal to the weight of the liquid equal to weight of liquid displaced by the submerged part of the cylinder, by the submerged part of cylinder. So important part is that the submerged part of the cylinder. So let's find out how this submerged part is going to be dependent upon the will result in a different buoyant force. So we can say that for less dense liquid, denser liquid, its density is given as d. So therefore we can find out volume of the cylinder submerged, volume of liquid submerged will be equal to total is length is L and denser it is given as L by 4. So this is our L by 4. So obviously lesser denser will be this part and this will be coming as 3L by 4. So volume of the liquid submerged will be equal to total length 3L by 4 and multiply by its area of cross section, that is going to give us a volume. So therefore buoyant force is equal to, let us suppose it is F less dense is equal to its density given as D, volume we already found out, D with this 3LA upon 20 and multiply by G. Now we find out this was for lesser denser, and let us find out for more denser. For more denser liquid whose density is 2D. So volume of the liquid submerged, volume of cylinder submerged, my mistake, volume of cylinder submerged. Okay, so volume of cylinder submerged will be equal to, and the length is L by 4, area of cross section will be same, that A by 5. Therefore we get the buoyant forces, buoyant force, let this be called as F more dense, will be equal to density is given as 2D multiplied by LA divided by 20 and multiplied by G. So we found out that buoyant force because of the more denser and buoyant force because of the less denser liquid. Therefore the total buoyant force will be the summation of these two. You can say total buoyant force, therefore total buoyant force will be equal to F less dense plus F more dense. So we get F total is equal to, we have this as d 3LA divided by 20 multiplied by G, plus here we have 2D LA divided by 20 multiplied by G. So we can take DLAG common. So this becomes as TLAG, and we can take 20 also common. So this becomes 3 plus 2, and this is equal to DLAG. We have 5 upon 20. This comes as 4. So we get as F total will be equal to 1 by 4 DLAG. So this is the total buoyant force. Now we know that buoyant force will be equal to weight of the object, that is cylinder. So we know weight of the cylinder and we know total buoyant force. We are going to equate them. So let this be equation number 1. So from equation 1 we get DAL upon 5 multiplied by G is equal to 1 by 4, and here we have DLA multiplied by G. So AL and AL goes away, G and G also cancels out, and this comes equal to D by 4. So density of the solid cylinder will be equal to, so D is equal to 5 by 4 times small d. So this is the density of the solid cylinder. This is the density of solid cylinder. And if we see the option available to us, we can say that option number A is the correct one. Option A is correct. So this completes the question. Thank you.